Hello, and welcome everyone to our today's episode of OpenShift TV Coffee Break. I'm Andrea Obiali, EMEA SA for Partners and solution architect for Partners. And we have today two guests. If you guys remember, in one of our previous chats here at OpenShift TV, we had spoken about the highlights of KubeCon and Cloud NativeCon. And uh, one of those that really raised attention among our audience was the recent announcement by Red Hat and about Red Hat Device Edge. And so we thought we would invite somebody who could talk about it, and who best than the PM and somebody with a lot of experience about it. And so we have here Daniel Froehlich and Stefan Bernstein. And why don't you guys introduce yourself? Meanwhile, I'll have my coffee.
You have your coffee? Okay, I have my coffee also prepared, and I have a nice latte here. So,
Oh, wow.
good coffee machine in place. Coffee is important. Hi, everybody. My name is Daniel. I'm with Red Hat now for over 6 years. I started also as solution architect. Then I transitioned into the global chief architect role for industrial. And in that context of industrial edge computing, I got really involved with edge computing. And then earlier this year, when all this productization effort of getting MicroShift to customers in a fully supported way, I was asked, hey, would you like to become the product manager for OpenShift Edge related components, features? And as being a product manager was on my bucket list to do in my IT career for over 20 years, I couldn't say no. So I recently transferred over to the engineering side of the Red Hat house, and now I'm the product manager OpenShift Edge. So I take care of all the edge-related aspects in the whole OpenShift portfolio. This covers also, for example, single node OpenShift, which is perfectly valid topology for edge computing also. But currently, most prominently, MicroShift, which is part of Red Hat Device Edge. And we will talk about that in detail later. So yeah, so much for me. And I hand over to Stefan.
Stefan.
Yeah, hi, my name is Stefan. I'm also solution architect here in Germany. I'm taking care of various manufacturing and automotive customers. And obviously, edge computing manufacturing is extremely important. The whole transition to have in manufacturing plants not only traditional visualization technology for hosting applications, but moving more and more into containerized workloads because of the ease of management, because of the frequent deployments, etc., is really a hot topic. And yeah, I'm looking forward for today's chat to hear and learn more about our new portfolio.
Well, Daniel, what have you prepared for us today?
Yeah, so I prepared a little bit of overview and introduction. So show some pictures and explain the story, what it looked like. A little demo, so we could simply install MicroShift and run it a little bit, and from there, it depends on what the questions are.
We do like demos here at OpenShift.
Yeah,
Coffee
I
Break.
know, and I'm quite famous. There's no presentation from Daniel without seeing a console, so I love that. I like also getting hands-on. So yeah, quick introduction into what Red Hat Device Edge and MicroShift is. So obviously, we have been born in the data center. I mean, we grow with Linux over the past 25, close to 30 years. Is it already 30 years? I think not yet. 30 years is going to be next year, something like that. So we have been born in the data center with Linux. We added JBoss middleware application services around that. We went out into the cloud because if you know how to manage hundreds, thousands of virtual machines or servers in a private data center, or in you can do this also in the cloud. Yeah. So that's basically where we have been in the last 5 years or so. But then trends like edge computing appeared, and the first iteration where this actually started is the telco space. If you look at a telco base station, mobile networking base station, they used to use specialized hardware devices, specialized switching network equipment, and they recently more and more transition to standard IT equipment. So at the base station, you see just a standard server rack infrastructure, and you do this stuff software defined. So you end up with hundreds or even thousands of remote locations where you need to manage your IT kind of infrastructure, like the operating system, security patches, monitoring, all that stuff. But it's not only telco. The same starts to happen, for example, in industrial, and this is how I came to it. Yeah, for example, in the factory automation space, if you think about programmable logic controllers, you have the same situation. They move away from specialized hardware to software-defined PLCs. If you think about point of sale situations, yeah, every supermarket is kind of distributed edge computing, and what's the big difference to cloud? Yeah, and that is what makes it challenging. Yeah, if you really go out to these far edge location, and that's one of the big differences compared, for example, to telco edge computing, which it is. First of all, for example, network connectivity. Yeah, in a telco situation, if the base station loses upstream connectivity, it has no business value anymore, and usually you have overlap anyway. Yeah, so you have a little bit of service degradation, yes, but it's not that critical if a telco base station loses its connectivity. Think about manufacturing. If a plant loses its upstream connectivity to the cloud, and the plant would hold to a grind to a hold this way, it doesn't make any money anymore, and it costs you thousands of dollars per minute. Yeah, so edge computing in the industrial space or in the point of sale situation. Yeah, imagine a cashier would not be working because you lose your cloud connectivity. That's not acceptable. So, but then also you have really constrained environments. Like, for example, in an industrial edge controller, in a far edge deployed small device unit, we are not talking about server grade hardware. We are really talking about single board system on a chip computers. Yeah, so that is a constraint. You probably even sometimes cannot guarantee the physical integrity of the device. It might be stolen, yeah, which is security-wise a completely different story. What about the lifecycle management? Yeah, how do you get updates out there if the device is only connected via, let's say, a small mobile network connection? Yeah, and pushing out, let's say, 20 gigabytes of virtual machine images is not manageable, right? And then, of course, the scale, you end up with thousands of, hundreds of thousands of devices. So that are kind of the challenges for edge computing, right? And but still, you would like to apply, let's say, modern application principles to it. Containerized applications, microservices, serverless, virtual machines, GitOps, DevSecOps methodologies, because that is why cloud computing is so successful. This scalability, reliability is based on these architectures. Yeah? We used to say, to name this cloud native applications. I hate that word because cloud native implies you deploy it to cloud, which you don't need to. Yeah? You can still deploy a modern microservices-based architecture to this edge device, for example, if it provides a reasonable, suitable base platform. Of course, you would need a container runtime, right? If your workload is containerized, if you have a, for example, containerized software-defined PLC, you just need a suitable container runtime operating system. And that is where we come to play. Yeah. But you need to find the balance. And that's the idea of Red Hat Device Edge. So we are quite famous and known for using, providing a rock-solid, scalable Kubernetes distribution with OpenShift. Yeah? And we put that in the recent years on a diet. So like 5 years ago, minimum system requirement was like six nodes, I think. Then we made it to compact clusters with 3 nodes. Then we introduced a single node OpenShift cluster, which fits on a single hardware. But still there's a gap. If you have this really small form factor field deployed device, which might have only 2 cores, 2 gigabytes of RAM, and you need Kubernetes, we couldn't deliver that, yeah, because OpenShift did not fit into that space. And that is why we invented MicroShift. And let me introduce here Red Hat Device Edge, because Red Hat Device Edge is actually a combination. So we start with a dock, the base workhorse, which brings you from A to B, and that is actually Red Hat Enterprise Linux. So that's the baseline, that's the base operating system, and then you could use this to run, for example, just containers. If you have a rather static workload, let's say 2, 3, 4, 5 containers, which are more or less fixed. They just communicate a little bit to each other and then implement the solution. And you don't need to do rolling updates, orchestration, adding, removing workload. If your workload is rather fixed, that is already good enough. Yeah, that is good enough to run your workload at the edge. But then you might have requirements to actually use Kubernetes as an orchestration tool for your containers, because we have, for example, a customer who does this for a point of sale solution, and they need to be able to roll out updates to their workload, to their application during business hours, while this server is running, while this component is running. And that's the sweet spot of Kubernetes, right? Remember rolling updates, yeah, scaling up, scaling down. You have load balancer integrated, which routes the traffic from the old one to the new one, all that stuff, yeah. So that is the reason why you might want Kubernetes even on a small form factor device, and that is why we added it. Yeah. And please also note that the dock has some special features, because that's the next variant you could use. So RHEL is the base, and then there's RHEL for Edge, which is RHEL, but in a different delivery format. Yeah. It uses RPM OS tree as a packaging format, which basically makes the operating system immutable, and you can easily add different versions to it, to the same disk, and boot to the different version, which gives you blue-green deployment. So you could boot into the new version, health check it, and if it's fine, you stay there, and if it's not fine, you roll back to the previous version, because both of them are kind of immutable, and you cannot easily mess around with it. And that is important if you are at the far edge location, where fixing a device, rebooting it manually, something like this, could mean fly in a helicopter, right? So you really want to avoid to brick your far edge device, and hence for these type of scenarios, we would recommend RHEL for Edge as the baseline. But you're basically, with Red Hat Device Edge, you have the choice. Yeah, you can use both, traditional RPM-based one or RHEL for Edge one. We expect the majority of Edge deployments to be RHEL for Edge. Yeah. Stefan, you look like you have a question.
Yeah, first of all, I was wondering what's the sunglass feature, but no, my question would be, you said you can have both RHEL for Edge and RHEL as basis. Anything else what I could use, either in community versions or for my home lab or other things?
Yeah, that's a typical question we frequently get, and the answer is a little bit twofolded. So technically, you can use probably we know it works, for example, on Fedora. Yeah. So you could use Fedora, you can use CentOS Streams, for example, also. You could even probably use Ubuntu on a Raspberry Pi. Yeah. So, but as always with Red Hat, you have to make the distinction what is technically working and what is fully enterprise supported. And there is a big difference, because fully enterprise supported, and that's the whole goal of Red Hat Device Edge, that we provide enterprise support for this Kubernetes at the far edge location. And we can provide that enterprise support only if it's our operating system. Yeah, because at the end, the cat has to fit on the dock. And if it slides always to the left or right-hand side, you might be into trouble. Yeah. So that is, technically it works on other systems, on other distributions, on our operating systems, but enterprise supported is only our RHEL.
Yeah. And you mentioned having, in quote, static workloads on Red Hat Enterprise Linux. That would be then static container-based workloads. That would be then Podman, right?
It depends on the workload. Of course, if your workload is containerized, you would use Podman to start this and systemd to do this orchestration and updating. For example, systemd combined with Podman also has the capability to check for updates if there is a new container image and stop the current one and restart a new one, stuff like that. This would be the preferred way for rather static workload. But if your workload is just RPM based, then just make an RPM install. If your workload is even virtualized, there's libvirt KVM. You can run virtual machines on this. It's fully supported, perfectly fine. Sure. And also even the combination, and we will see a picture of that, I think, now. So on the next slide, you can see it basically. So this is now the not dog and cat version of a more technical diagram. So you have rel. And here is a comment on Linux for Edge that we recommended. That's the baseline. And then, as I mentioned, you could run virtual machines using libvirt KVM. And then here is what MicroShift is, a component of Red Hat Device Edge, which you can optionally install. And that is actually we could do now or later in a demo. Just install it and see what's happening. So. The goal of this is that we provide workload portability, so Kubernetes workload. So if you have a Kubernetes-based application which you deploy, for example, using a Helm chart to your Kubernetes cluster, maybe in the cloud, the idea is that we get the same Helm chart, the same workload running on MicroShift. With as little, hopefully no modification at all. It should basically run out of the box. And that also explains that we have, for example, the really, really minimum Kubernetes cluster services there. So let me rephrase it another way. If you think about OpenShift, OpenShift has a lot of more services, and we put OpenShift on a diet to get it on a single node, but still it requires a lot of resources. With MicroShift, we started the other way around. We started with nothing, and then add only the bits and pieces you need to get to this workload portability capability. So we take a minimum rel, add what is needed, for example, a container runtime. Here you can see containers are added. We per default do not add libvirt. You have to add this if you need it. You can add the necessary packages. For MicroShift, we add just Cryo as a container runtime. And then, of course, Kubernetes etcd, which is basically what you need to have a Kubernetes orchestration, the scheduler. And then for cluster services, really, you need just networking, so the pods can talk to each other. You need some kind of ingress router, so you can get traffic into the cluster, because at the end, you would like to provide web front end, for example, REST services, whatever. You might need storage, because typically your workload has state. So we need a CSI storage provider, so that you can have persistent volume claims, persistent volumes. And that's basically it. That's the approach of Red Hat Device Edge. And for example, we have later a slide where I could compare this to OpenShift. But a really simple example is there's no console. OpenShift has a really nice web console. There is none, because it takes resources. And why would you need it on an edge location, right? You don't need it there. So command line tooling or external management. Use, for example, advanced cluster management, GitOps ways to deploy your workload and manage this. Yes, for sure. And that works because you have the standard Kubernetes API. So we are currently not yet certified, but we have it on our backlog list on the engineering items. Until we get to general availability, we have this certified as a CNCF certified Kubernetes distribution.
Cool. And physical, you have physical here on your slide. What about ARM in those directions?
Yes, ARM, as we support, so MicroShift is derived from OpenShift. It is not OpenShift, but it is derived from OpenShift. So we inherit a lot of features and capabilities from OpenShift. And that means, for example, as OpenShift runs on ARM, MicroShift is also going to be fully supported on ARM. And we target this especially, for example, if you think about machine vision use cases. So all the types of use cases where you would like to do model inferencing at the edge location. Think about, for example, point of sale situations where you have cameras watching the shop. In a factory, if you do visual inspection, quality control use cases to determine part is good or bad. If you think about, for example, flying drones, we have a customer flying this stuff on drones and doing model inferencing with that. And for example, NVIDIA has a really nice capabilities if you look into the NVIDIA Jetson devices, where they have really nice the critical factor is compute power to power consumption. If you're on a field deployed devices running on a battery, how much compute do you get for power you invest? And NVIDIA ARM Jetson devices are really good in this, plus adding GPU power for visual, for model inferencing. That types of use cases we explicitly target and will support this. It's still a long way to get rail running on these latest ARM devices. Getting the drivers into the right space is a long story short, but that's my job to take care of as a product manager to get it.
So is it fair to say that so obviously you have the dependence on what hardware architectures, what platforms are supported by OpenShift and hence by MicroShift. And then maybe you'll be able to explain to us how essentially MicroShift is derived from what code base. That would be interesting to know. And then what is supported by Linux for Edge. And the intersection will give us what are the hardware supported.
So basically the slogan for OpenShift is OpenShift runs where rail runs. And if you have a question, and does OpenShift run on this or that bare metal server, you simply look into the hardware certification list in the catalog we have, and I could show the link if you like. And if you look into the hardware catalog, actually there is no specific certification for OpenShift. You just look for RHEL 8. And the same holds true for MicroShift. So if you have a hardware device which is certified for at least RHEL 8, RHEL 9 even better, then you're good to go. We will fully support you. If it does not work, we will work with the hardware vendor. And if you have a new device which is not yet on that list, just let us know, let the hardware vendor know, and we would work with them to go through that hardware certification, which is not a big deal. Basically, you need to define a test suite, run a test suite, submit the results, and then you are certified. It's free of charge. It's not a big deal. And if the test suite finds an issue with the driver here, driver there, we would support that hardware vendor to get it fixed. Might be complicated if you look into, as I mentioned, NVIDIA Jetson. And that is then we really do joint engineering work with the hardware vendor, with the communities to get the necessary driver to where they belong.
Okay.
Did I forget some question to answer?
No. If anything, I mean, on the topic, there's also the topic of having base images for that architecture, and obviously having the software factory that generates the base the final images that will run on that architecture.
That was, for example, a challenge if you look here at the storage. So we use ODS LVM, which is based as OpenShift Data Foundation Logical Volume Management, which is basically a CSI driver based on the upstream community Topo LVM project, which is really nice because it maps. It is a CSI driver which is backed by an LVM volume, the logical volume manager of Linux. So if you create a PVC under the covers, it creates a logical volume, which is nice because it creates isolation, quota enforcement. You can even get snapshots. That is really nice. So we decided to use that Topo LVM or ODF LVM as a storage provider for MicroShift. So it's included, because we fully understand you need state at the edge. I mean, it's all about, so you need to store some data. But when we first ran our first test on ARM, the challenge was getting ARM container images for ODF LVM. Because they were not yet there, or they were not accessible to us, and getting this all worked out, who provides what, is kind of a challenge. But we are there now. So we have, for example, in our engineering CI pipeline, we build MicroShift for ARM on automated regular basis. Yes.
You mentioned that, and maybe we're gonna look at that later on in your presentation. So you mentioned CSI. So how do I find out what CSI drivers are supported?
That's basically simple. We ship and support only ODF LVM, because that's what we test. Of course, it's a soon-to-be certified Kubernetes distribution. So in theory, you can add whatever you like, but then you have to work with the CSI driver provider if it's supported. For example, the really simple one like host path, local volumes, they work for sure, but you need to talk to the vendor, to the CSI driver vendor, if it's supported from their side. We support Topo LVM. We ship it. It's per default. It's there. That's included in the subscription.
Still lots to talk about, so I think I'll let you carry on. It's probably we will have to invite you back again, because I think there's still a lot to talk about.
Right.
You promised the console, Daniel. So
okay. Now time for a console. Okay. So as we see this picture, I've prepared in the kitchen the base. So I have here a Linux, not for Edge, because on Linux for Edge you cannot easily RPM install something else because it's immutable, remember? So hence I took the RPM based one. And here is a really simple console. And Andrea, if you could maybe make this a little bit more, to move us to the bottom line.
Yes, I'll try and do that. That didn't work that well. Let's do this for now.
That's nice. Thanks. So taking a quick look. So this is a standard RHEL 8.7, right? So and I prepared all the necessary stuff so that I can simply DNF install MicroShift. So basically it's an RPM package, and it has a couple of dependencies we will see. So it will now contact the repo managers, and here you can see that I would like to install MicroShift, and it's really small and tiny. It's just 26 megabytes in downloads. Doesn't matter really, because usually you don't download it, you have your image prepared, but just to make the point of size, because size doesn't matter at the edge. And then you see dependencies, as I mentioned, for example, Cryo as a container runtime, and networking stuff, SE Linux rules, because security is one of the primary concerns for edge locations, and OpenShift is famous for its multi-layered security approach, and we follow that alongside. So let me, so in total, it's like 85 megabytes in download. On disk, it would be 350 megabytes. That's not all. We need some more stuff, but let me simply add yes, so that it's downloaded and installed. So yes, that's okay. Please do it. So this now takes a couple of steps to do the installation. And by the way, this is a virtual machine actually running on my laptop, and it has 2 cores and I can't remember, was it 2 or 4 gigabytes of RAM. So really what we think is a field deployed edge device, really small, limited. That is why stuff like this, for example, installing sometimes takes a little bit of time. So let's wait for this. It should be.
And Daniel, quick question. So is there any other prerequisite from the operating system than what also RHEL has versus RHEL for Edge? Is there any specific, or if it's just I need some minimum CPU and RAM, and that's it.
Minimum CPU, RAM, RHEL, base install, and then it depends on what you need to feel comfortable on the system or what your security guidelines require. Basically, the core dependencies are here this cryo container runtime, and you can see, for example, OpenVSwitch, because we use as a CNI provider, the networking interface provider, we use OVN Kubernetes. So we need, for example, OpenVSwitch stuff.
And while storing, and you mentioned Ingress, and people who are familiar with OpenShift know that OpenShift has the route concepts, which is pretty similar. Is it still based on the route concept, or something else?
Yes. So the route concept is kind of is the old name, or which we invented. If you look into the standard Kubernetes API, it is Ingress controller objects, and we implement this using HA proxy. And yes, that is there. So now I installed it, and now I need just to start it. So I system enable MicroShift service. You need to do some, if you want to access it from external, do some firewall enabling. I did prepare that already, or I don't need it. But basically, now I started. And what now happens is a couple of containers are started. Because, for example, exactly the router, the Ingress controller, is running containerized, like also the networking or the CSI provider. So these container images need to be downloaded here in this version. So I need to download all the images, and we will see them starting pretty soon. That is also one of the beauties of if you would use RHEL for Edge. RHEL for Edge has the capability to add your container images to the OS tree image. So and now I need to get access to it with a kube config, and I can also get pods. Take a look, and we should see now the pods. Here you can see the container starting. So this is now pulling the container images I was talking about earlier. The goal we have, and we have showed it multiple times, that you can have a fully self-contained OS tree image where everything you need, so these container images, which are pulled as we speak, but also, of course, the workload. You can all of this embed it to the OS tree. It becomes part of the immutable OS tree commit. And so you don't need any network connectivity to fire this up. And even, for example, the manifest, you need to deploy these container images. For example, if you have deployment, service account, service objects, Ingress objects, all the typical stuff you have in your Helm chart to deploy your application. You can add these manifests, the YAML files, also to the image, so that MicroShift would automatically fire this up at startup. So you could really have a fully self-contained image. You could even burn this to a USB stick, go to the edge device, plug it in, turn it on, and it would install, fire up, no networking, nothing. That is an option you have. So
one quick additional, because I'm getting that quite often, also in demos, is you typed OC. Could I use kubectl?
Yes, of course. Actually, it would be probably better to do that. I'm sorry, I grew into the container Kubernetes space with OpenShift, so I'm familiar with OC. It's a kube API, so kubectl, and I should have it. Kubectl get namespaces should work. Or kubectl get nodes. Of course, you can use it. Actually. Now that is a good point. So there are differences between MicroShift and OpenShift. Remember, MicroShift is not OpenShift. It does not provide the full OpenShift capabilities, and capabilities boil down to APIs. So there are OpenShift APIs, which are not Kubernetes APIs, but OpenShift specific extensions, which are not available. For example, OC get build. Remember, OpenShift has the capability to build container images on the platform. If you are on a development environment, this is a rather good idea. It's not working. every time you see the server does not have a resource type build, it means that the OC client, which I simply use the standard OpenShift client, that does not have this API. So that means this API, the build API, is not supported by MicroShift. Basically, we have a list. So the Kubernetes API, to get certified, it's fully supported. From the OpenShift API, actually, next to nothing is there, because it turns out you only need SCC, security constraints, and I think routes, I think it is. And everything else is not there. So every time you see this error message from the OC client, you hit an API which is not yet there. And we did this on purpose to really keep it small and simple, because for every API you add and support, you need a controller that consumes CPU, RAM, especially, and memory. And to shrink it really down. Yeah, but let's see. Here we can see the nodes. It's just one node, right? And the pods should be firing up. Yeah, see, now everything is running. And here you can see, for example, the router, the ingress router. Yeah, it is in the same namespace. It's like the OpenShift router. It is the OpenShift router image, actually. Yeah. So everything is there. And we could, for example, also now check that we have images, a couple of images downloaded. Yeah, here you can see, for example, the CSI driver images, which are being pulled. So it adds like currently kind of 2 GB of additional disk space, which you need for container images. We are on a trajectory to reduce image sizes further. But overall, for example, getting this up and running on a small form field deployed edge device, which has, let's say, a 16 GB SD RAM card, that works. Yeah. And if you take a look into...
Can I interrupt you for a moment? You did mention something. So it's this is what you have here is a single node. Could I add nodes to the cluster?
That is a good question. Simple answer is currently not. No. We have that capability in single node OpenShift. So you can add additional worker nodes to single node OpenShift, which sounds strange. And to be honest, I don't like that, because it gives you a really false sense of high availability. Yes, what you would get from that is workload high availability. So you could scale your pods to 2 different nodes, and if one fails, you have that. Yeah. But what about the router? Yeah. You need to scale up the router. Now you need external load balancing, or you need keep alive the stuff like this to get the load balancing. And still your control plane remains a single point of failure. So for that reason, adding nodes to MicroShift is currently not supported, and we have it explicitly out of scope, because we would like to avoid to give you that false sense of high availability. What we suggest to do, if you need a little bit of redundancy, simply add a second device to your deployment, so that you have 2 devices on your deployment, and do that failover on the workload side. Yeah, these devices can detect each other, talk to each other, and do a, let's say, active passive type of workload or a high availability. Yeah, but there is a reason why etcd needs 3 nodes to become high availability. Yeah, because if you are only in 2, you always get into the split brain problematic. If you have state, who is the leader? This is really dangerous. And if you have truly serious high availability requirements, a 3 nodes OpenShift compact cluster is the weapon of choice. Yeah, because that's rock solid. There's no single point of failure. It's proven, and that's the way to go. That covers you in all the situations, because if you consider high availability seriously, you simply pull the plug. That's the easy situation. Yeah, it's not really alive, but it's also not really dead types of situation where a device sometimes responds or sometimes not. That is really hard situation, and you need 3 nodes, a tiebreaker for this to get out of this. Yeah.
So the way I read it, and sorry for being a bit cheeky, is not now, but if we were to do it, it would be a 3 node. It would be a 3 node configuration, but not now. And this leads to another question, which is, what are, and maybe you have that in your presentation, what are the good use cases and the bad use cases, if you wish, the ones that you, for for edge device?
Good point. Let me quickly jump over to this. So we have a really high-level decision tree, but basically, as always, the answer is it depends. As an architect, you have to understand the requirements, and there are a lot of things to look out for. The first one is what's actually the use case, the workload. Yeah, how is it containerized or orchestrated? How dynamic is it? What's the networking requirements? How is it connected to the front end, back end? What protocols go in? What protocol goes out? Yeah, how do you connect your USB device, for example, your PLC? What type of networking devices do you need? And depending on that, yeah, you get a feeling, is it, for example, more server-grade hardware, or is it a really field-deployed devices? Yeah, and that is basically as soon as you end up with, let's say, servers in a more or less controlled environment, like in a rack. Yeah, and for example, telco base stations are, from our perspective, already a controlled environment. Yeah, because you have a rack space, decent power supply, typically already redundant, emergency power. So that's the right-hand side of OpenShift space. Yeah, and really the field deployed edge devices, that's where Red Hat Device Edge is targeted for. And then you take a look at the workload. Yeah, how static is it? How dynamic is it? And that could bring you to Podman, or if it's virtual machines, you could add virtual machines here. And only if you really have the need to Kubernetes. And I would, for example, also add, do you have the capabilities? Because, I mean, Kubernetes is not for free. It brings complexity. You have to understand that. For example, how to do a rolling update correctly. The workload has to be able to do that. Yeah. If you put an old monolithic application into a single container that requires 12 cores and 20 gigabytes of RAM, it doesn't add any value, right? Yeah. You need to really go down into this microservices, rolling update, modern application development, and yeah. So that would be kind of my guidance. If in doubt, I would suggest go rather with a single node OpenShift. For example, we will see that it works on 4 cores already. Yeah, it is also a perfectly valid choice. Yeah. So and also people tend to forget other topologies, especially in the factory deployment, that you could simply use a worker node or even a remote worker node topology. Yeah.
You mentioned network, what type of network and all that. This question mirrors a little bit the previous one. So, which are the CNI drivers that are supported in edge device?
So currently we only support OVN Kubernetes.
Okay.
And we switched to that because it's used in OpenShift, so we know how to maintain, update, fix it. Also because it supports network policies. Yeah, that was a feature which we have been asked from customers about, that they would like to be able to isolate their dynamic workload on the small edge device. So network policies are asked. We are also currently looking into adding Multus, which is kind of the umbrella meta CNI driver, but that is currently not supported. Yeah, so it's OVNK.
We also have another question. It's coming from the chat. It's Chris who's asking this. Is MicroShift being user tested in production anywhere?
Good question. So you could say yes and no. So for example, we have, let me quickly jump to that. MicroShift is actually flying in a CubeSat in space. Yeah. That was a really early research prototype. Do you consider this production or not? Yeah, it depends. So this brings us to the question on how do you get to production? So what's the state? So we announced it here with at KubeCon. And I must admit, currently it's not yet used in production, simply for the reason it's not yet general available. Because typically, with Red Hat, production support comes with general availability, yeah, and we are not yet there. So the road to there is as follows. I think I somewhere have a slide on this. At least I hope. Actually, I don't. That's a bummer. Okay, let's keep on that. slide and let me continue. So the road to get into production and get enterprise support is we will be in developer preview in January with OpenShift 4.12. So it will be available to everybody. Yeah? But developer preview comes with no support. We have a couple of customers who are on the early access program, and they are in tech preview. So they run this already, and they run this in their test environments. They run this in, let's say, friendly customer deployments. It's not yet fully in production, but they are working with it. They are using it. And we have all different types of scenarios: industrial, defense, retail customers using that. And they would be able to go to production because they are on tech preview. And with tech preview, you need just a support exception to go to production. So we expect first customers to be in production early, let's say, Q1 next year. And with the following OpenShift release 4.13, it's currently in the planning. If we get into GA or tech preview for everybody, we will see. And then, let's say, later next year, it will become general available. And the reason it takes so long is we have to do the transition from the office of the CTO, where it was invented, to the regular OpenShift engineering teams. And also the support teams need to be enabled, because, I mean, that's at the end the value. We provide support for it, so we have to enable our support teams to be able to handle a call. My MicroShift is not booting, I'd say, Saturday afternoon, and you need somebody to help you with that. Yeah, and that would be us. Yeah. So we have that, and regarding as production also, so we have this one. We have a joint announcement with ABB. They use it for their Edge Genius industrial IoT solution. As I said, it's not yet in production, but we have a joint announcement. And another one is Lockheed Martin. If you watch, for example, the YouTube video which we have with Lockheed Martin from KubeCon, where they show the details about their use case, as I said, MicroShift flying in drones. Yeah, that works nicely. Okay. Yeah.
Where were we?
Very good. So we could talk a little bit more about the differences, or we could talk about the different topologies. Yeah. What do you think would be of interest?
For me, interesting would be also management. How do I manage the things?
Yes.
Yeah.
So you did mention something. You said,
yeah,
well, there's no console, but you wouldn't want a console on a remote device that's in the field. But you mentioned also ACM.
Yeah. So let me quickly switch gears. So I have to log into another virtual machine where I did prepare this. So this is again MicroShift running. But if you take a look into the pods are running, you can see there is, for example, an MQTT message broker running, but much more interesting is Open Cluster Management is running. So what I did with that MicroShift cluster, I added it to Advanced Cluster Management. So Advanced Cluster Management is our way to manage Kubernetes clusters. Yeah? Distributed in the data center, in the cloud, or at the edge. How does it look like? Let me quickly find now a nice console. Yeah, so this is an ACM hub cluster. So ACM has the concept of you have the hub cluster, which is the central management touch point, where you can manage your clusters, you can manage your applications, you can manage your security policies. So if I take a look, for example, into the clusters, you can see I have a couple of clusters running here. Yeah, most of them run virtualized, some of them run bare metal, some of them run somewhere in the cloud. And here you can see I have an MicroShift cluster running. So that is actually the MicroShift cluster we have just seen in the virtual machine here. This is running on my laptop. It's connected to the management location, which is actually running in a Red Hat data center. So this is kind of far edge already. Yeah? If I lose the network connectivity, it would disappear here. You can see it's ready, so it's connected, it's live. Yeah, and we could take a look here and see, for example, hey, it has only one node. Yeah? All the management add-ons are deployed. So of course, you can add only the agents you need. So, for example, if you say I don't need, let's say, security policies, you can skip that and do not install this. Because of course, if you add workload to the cluster like observability or the policy controller, it adds to your footprint. Yeah. So all of this is roughly half a core to a core, which it requires currently. We are on the trajectory to minimize this. Yeah, we expect like half a core you need for this management, and maybe rather memory hungry, especially the observability part, which is like 2 gigabytes of RAM, maybe more. But for example, if you have the observability controller, you can go to the multi-cluster observability, which is part of advanced cluster management. So I could switch over to the Grafana. So that is the ICM cluster overview, where you can see all of your clusters and see the health status of all the clusters attached to it. Yeah. And you can see, for example, my local MicroShift is also here. So I could switch the view on the management location. Keep in mind here, I'm in the Red Hat data center. I'm connected to the data center, but still I can, if I find the right dashboard, Kubernetes compute resource per cluster should be this one. If I select my local cluster, I see, for example, the CPU utilization over the last 3 hours, and I could probably go back to the last week. And here you can see, for example, it's not going back to last week because I just started it yesterday. It's not running continuously. But yeah, so here I can see on the hub cluster, I could inspect the cluster, what's the CPU load, memory utilization, and for example, which resources are consuming most of the CPU. Yep. And the same is for events, like if the cluster submits alerts. Yeah, that would also work here. So that is basically the way to manage workload. And we could now, for example, add an application to it. Yeah, so you can also add applications to this using GitOps, for example, and that would then roll out the application to my edge node. Yeah. What you currently cannot manage is the actual cluster lifecycle. So while ACM is capable of, for example, provisioning a cluster on a bare metal or in a cloud, it cannot currently deploy a MicroShift cluster on a RHEL for Edge device because it does not know how to handle RPM OS3 RHEL Edge systems. Yeah, that's on the roadmap that you would use actually Red Hat Edge Manager to do that, which is a different console. We could look in if you like. Yeah, to manage the base Edge systems. Yeah, for example, add RPM packages, build these OS3 commits, make them available to the edge systems. That is a different console. If you like, give me a thumbs up and we take a look.
So there's a question that comes to my mind exactly about managing workloads. And so RHEL for Edge itself has over-the-air updates capabilities. And you did mention that I can prepare the template of an image, if you wish, for all, let's say, my devices of a certain release for my, let's say, hardware that I had to put out in the field. And so that image will also contain the container images, and even all the definitions of the resources that they have to have. So now, however, we are in a different situation where I could even use ACM to deploy or update applications as well. Those are not mutually exclusive. I guess you can have one or the other and decide how you manage that.
Yeah,
right?
you have to make your choice. Yeah, if you have, for example, rather static workload, I would go with the first one, embed the container images. Also, if your devices are usually disconnected, do not have good network connectivity, it's probably a good idea to manage that. It also depends on how you do the overall device lifecycle management. Yep. If you are in a more dynamic environment where you see the devices are usually quite well connected to your management location, could be in your data center, could be in the cloud, then this one would be the weapon of choice, but even a combination would be fine. Yeah, for example, to deploy the baseline application using the static images, you even can later add dynamically images. So there's actually the container runtime has two locations for images, one which points to the immutable OS tree part, and the other one which is the regular dynamic var run container image location, var lib containers, I think it is something there, where you store the images. So, and you can then pull updates to container images, and then it just depends on the image version your deployment points to, because you have both images located on the edge device, and whatever your deployment points to, that is being started. So yes, but it requires thinking. There is no one solution fits all. You really have to understand the use case, the management aspects, network connectivity, all the various aspects, security. We did not deep dive, for example, into the security aspects of this. How do you get a secure device provisioning done? Yeah. So can you trust that device at the far edge where you cannot guarantee physical integrity? How do you handle that? Full disk encryption. Yeah. That would be another coffee session to talk about this. Short answer is it's not easy to get it right. We have a lot of solutions and layers which contribute, and you carefully, as always with security, you have to carefully think about all the different attacks layers, how to protect it, how to get your software supply chain trusted, and all that.
Thank you. Sorry for disrupting your flow with lots of questions that were coming. There was one coming from the audience again. Not sure if I understood. Was asking about cluster management and the lightweight control plane use case, which I'm not really sure I'm familiar with. Hopefully
lightweight control plane, is this like HyperShift? That's a completely different story.
Yeah, I'm not sure. No, we'll park it, and then we'll see if Charles can a little bit clarify what his question is.
Yeah, what I mean, lightweight control plane could be HyperShift, which is something completely different, or it could be actually MicroShift. I mean, it is a lightweight control plane. It's control plane is running, yeah. But that fully works, and that's the reason why, for example, advanced cluster management so easily works, because all these agents we are seeing here are talking locally to the Kube API, which is the lightweight control plane of MicroShift, and they would talk to add, for example, the necessary manifest to deploy an application. Yeah, that simply works. Yeah.
And one thing what I was thinking about is, what about operators? So we have the we have the operator hub, operator lifecycle manager on the full-blown OpenShift. And I'm now coming from the application side and think about, well, if I have a small application for the edge that has a small database, be it a Postgres or whatsoever, I can easily manage that through operators on OpenShift. Would you recommend them to do this also on MicroShift, or say, well, in this case, use Helm charts or whatever? Because
it depends. Now we're running 5 minutes could be enough. So
sorry,
difficult questions, because we removed a lot of or actually all of the OpenShift internal cluster operators, because they take a lot of resources and they're not really needed. And also, for example, the operator lifecycle manager is not yet there. So you cannot simply easily via subscription add an operator from the operator hub. That's not possible. Also the updating of the operator and so on. That's currently not there, which makes people think about MicroShift does not support operators, which is wrong. Because actually, if you can deploy the operator via, let's say, for example, traditional manifest, and the operator uses only the standard Kubernetes API and has no dependencies on, for example, let's say the machine config operator, which is not there, then it actually works. So you can deploy Kubernetes operators, and that would be also my recommendation. if you need to run a Postgres database, a message broker, something like this, of course, you have to make the trade-off because each operator you deploy also consumes resources, mostly RAM. But you can do this. And actually, if I go back to my, here you can see that my AMQ broker deployment here, that is actually here. So this is the actual message broker, the MQTT endpoint running, but here's the operator running. So actually, I did deploy an operator to it, but I just used the manifest. And now, the really important point is you have to talk to the provider of that operator if they support that.
Right.
Yeah. So, for example, with all the Red Hat operators, we still need to go through that exercise. The default answer is it supported? Probably not. You have to talk to the necessary teams to find out. For example, if you use a Kubernetes operator for Postgres from Crunchy, you have to talk to Crunchy if they support a manifest deployment to MicroShift to get enterprise support. That is something
But once again, for your disconnected use case, you still can, let's say, create the manifest, or you're creating your own operators for your own workloads. You can put it in there, and you know, as soon as you got the image, that's all there. So yeah.
Right, exactly. Yeah, and that is what we mean with the workload portability, and that is why in this diagram we have the Kubernetes operators on top. Yeah, because technically it works. Now your support mileage will vary. You have to check, and also especially test the dependency. Yeah, as I said, if the operator uses something, an API which is not there, it doesn't work.
So if somebody wants to try it, now that's imagine it's not yet in tech review, right? But if somebody wants to play with it, who they do now?
What could they do now? They could go to the best thing I think is OpenShift, MicroShift. Should it be? Go over here, go to the docs page, and I will paste the getting started link into the chat if I can.
Do that. Yep.
I put it over here, and I think Andrea, you can post it.
Absolutely.
That's the easiest way to get started. Yeah, which gives you instruction on how to run it on a virtual machine, as I'm doing it here. Yeah. Could be the instructions are for libvirt on a Linux system. Sorry, we are a Linux company. We use libvirt as a hypervisor. Yeah, but basically, if you use something else, that also perfectly works fine. Yeah, take a RHEL 8.7 base image from AWS, whatever. Yeah, and then follow the instructions, and you're good to go. That's the easiest way to get started.
And I guess that's what we have time for today. So, couple of comments at the end. I think we'd like you to come back, maybe when it's you know, for the 12's out, and give us the updates, a little bit of roadmap, and maybe talk about more about use cases, because I think that's the interesting part. And but for today, thank you very much, Daniel. Thank you, Stefan, for your contribution, and thank you all. And see you next week with OpenShift TV.
Yeah, it was good fun.
Thank you. Have a good day. Bye.
Bye.